Hey guys, uh, welcome to our last day of notes about limits. We're going to learn one more concept here, which is about how to use limits to find the slopes of tangent lines to curves. Y'all may remember tangents from circles. A tangent to a circle would be a line that touches a circle in only one place. Here we have some random function I made up, y equals 1/4 x squared. And the tangent line to this curve, and say the point x equals 2 and y equals 1. The tangent line is like there's a line, this line here that only touches the curve once. It doesn't cross it in two places. It doesn't cross it no times. It hits it exactly once. And at any point on a curve like this, there's only one tangent line. So this is the only one I could draw at the point 2, 1. This one, it doesn't cross it. And if you think about the slopes of all these points, this one fits. You don't have to worry too much about exactly how this works. Just know that this is the only line you can draw that's only going to cross this curve one time. You can see that x is 2, and when x is 2, y equals 1/4 x squared. So when x is 2, x squared is 4. 1/4 times 4 is 1, so this point is 2, 1. And I just wanted you guys to see that so that you can understand where we get the y's. Once we have the x's, you always just use the function expression. So let me show you like the process that somebody thought of years and years ago to figure out how to find the slope of this line. Because maybe you can see like when x is 5, it's going to have this curve will have a different slope. Like when x is 5, the tangent line would be steeper. And we're going to see like a bunch of different ones of these lines here in just a second. So I'm going to switch the sharing to a different screen real quick. And I'm going to show you what I'm talking about here. Here now you can see this is a little Desmos graph, and it's the same curve, y equals 1/4 x squared, and there's the point 2, 1. But I'm like, what if I drew a line through, this is a tangent line here, but what if I drew a line that touched this point and that point? Like it doesn't just touch the curve once, it touches it twice. And that would be this line right here. You can see that it hits it twice, and that line, maybe you can't really tell, but it's called S because the S stands for secant, S-E-C-A-N-T. I'll write that down in a minute. But these lines that hit the curve twice are called secant lines. And you can see if I move the green, like the slope of this line is changing. It's getting steeper as I go up, and it's getting shallower. I don't know what you call that, flatter as I go down. You can see here's a point where x is 6. This is a point 6, comma, can I get there? Oh, so close. This is about 6, 9 right here, 6, 9. And then when x is 4, y is about 4. 4, 4 is going to be on this graph for sure. It is right about there, and so on and so forth. Like, and this is the point. As this green point moves closer to that purple point, like as I slide closer and closer to the purple one, you can see that that green line, which is the secant line, is getting closer and closer to being the same as the tangent line. And boom, when I'm right on it, there's only one line. So like that's kind of the process we're going to do here is we're going to start with some line that's a secant line, as in not the tangent line, and we're going to make it into the tangent line by letting the green point get as close as we can to the purple point. Basically, we're going to think about if this point is 2.03 and 1.03, that's my problem. That's why these things aren't exactly right. A equal to 2. Not good. If this point is 2, 1, and this point is 6, 9, what I'm going to do is I'm going to say what happens as the 6 gets closer and closer to the 2 is that the lines become the same line and the slopes become the same. So to figure out the slope, I'm going to let the difference between this x coordinate and this x coordinate, I'm going to take the limit as that difference approaches 0. When that difference is 0, go to the same line. So that's just kind of the basics of what we're doing here. I'm going to demonstrate this with 2 specific points. when x is 6 and y is 9, so that's this point right here. And when x is 4 and y is 4 right here, and then I'm going to take the limit as the difference between the x coordinates, between this x coordinate and that one goes to 0, and I'll show you how to find the slope. That'll come up in the next one, so take a look for it.